Okay, so let's have a quick look at how we're going to change this charging setup to accommodate this new charger, this new Orion XS. So the first thing you can see on the Orion XS is it needs an in, a ground and an out. So the in is from the starter battery in my case, and the ground will be the main boat ground because the ground is shared between all the batteries on this boat, and the out will be to the house bank. So that's what we need on this side. If we have a quick look at how the engine's currently set up, this wire here coming off the back of the alternator goes down here, along here, and then it goes up to the charge diode that's up in the corner here, and from the charge diode it then comes back down on another red wire and connects on the back of the starter solenoid, which is there. On the other side of the starter solenoid, you probably just can't see just there, if I just go a little bit closer, this wire is the main starter battery cable. So this is a big chunky cable, this guy. So he's going all the way around and over there to where the batteries are kept. So that's all great. However, a couple of things first of all to notice. First of all, these two cables need to be joined together in the new world, because if you look on here how it works on this diode, you can see that there's three cables on the diode. The left one is the house bank, the middle one is the alternator, and the right one, this one that's labelled number 1, is the starter battery. And that's how it's set up at the moment. So starter battery and alternator need joining together for us. We don't want them to ever be separated, otherwise we'll not be charging the battery and the alternator could be sort of dishing out power. So for us, we've got to try and join these two together. Now that's fine, we can just cut the thing out, get ourselves a nice bit of chunky cable here and join this together. And that's probably the best thing to do, is to join this with a really heavy bit of cable, because the cable that I'm sort of putting for maybe a little bit heavier. It's a little bit heavier than what's currently on the boat at the moment. Now, from the battery up here, so from battery number 2, this one, this goes over underneath here, along here, round the bathroom, and heads that way. And in there, it meets another chunky cable like this one behind the switch panel. So it's not a small cable the whole way, it's quite a big cable, but there's a section of it which is lighter. So I probably won't end up ever using that cable again. We'll probably just disconnect that and just put it somewhere safe, because this Orion XS is going to end up over there closer to the batteries. So yeah, so I think that's probably what we're going to do. We'll keep the battery cable lengths as short as we possibly can. That kind of makes the most sense. We'll upgrade the cable that we've got here to make that link between the alternator and the starter as big as we possibly can, and then we're already into the heavy grade starter battery cables anyway, so we've got no issues on that side. And we mean removing a few more cables from down here, which is always nice. We don't need them anymore, so they might as well come out. And it makes this Orion XS be as close to the batteries as possible, which is what it recommends in the manual. It'll also be a little bit better for heat, because the engine room can get quite warm. As you can see, they've changed the design of this a little bit, so it actually stands off now from the back. So I think these are more efficient anyway. This model, this XS model, it is the most efficient that kind of Victron have come out. It's super light as well. There's no weight to this at all. Well, it looks a little bit sad at the moment, but we are making good progress. So obviously you can see that the alternator is now missing from here. That needed to come out because one of the nuts was stuck in the back. The earth wire, one of these little earth wires that's just buried down there, that was actually stuck on it. So I had to take the alternator off. I'm going to take the alternator back now with me and clean that up. but I've just spent the time removing these red wires, taking the tape off everything. Please don't use tape on stuff, just cable tie it or use Velcro ties, because it just degrades and then everything's sticky. So just show you this side. So on this side, you can see obviously the alternator's missing. Here's the main sort of starter wire that's normally attached there. So we're going to upgrade that from the link from the back of the alternator to here. So that's done. I've taken one of the earths off the engine. Obviously the alternator is earthed through the engine itself, but there's also another small wire that goes from there to the alternator. So I'm just going to clean that up. There's the main engine earth. So that's that one. And then I've removed some of the additional wiring that was here that went to the box. And I've also taken off the starter and the alternator wires from there. So it looks a bit of a mess at the moment, but we're making progress and we've stripped quite a bit of wire out, so that's good. Okay, so we've got the alternator here from the boat. And the reason I brought it home is because some of these, well, one of these nuts really was stuck. And I had a bit of a job getting the earth cable off it. I thought I'd just have a bit of a look at them just to make sure that I wasn't spinning kind of that stud round in the alternator itself. And also have a quick look at this, because this is the regulator. So we just go back to this for a second. You can see here that on this one, let me just undo that. So you can see at some point here that this bolt, this stud that's in this, it has sheared off. And it hasn't got the same amount of nuts on as the rest. So I'm just going to see if I can put another small nut on that, and then I can clamp the wires between the nut that I put on this and this one that goes on the top here. So that's my plan with that. That'll kind of just sort that out, and then we won't get in the same situation again where this thing's spinning round. The others all look fine, and so does the alternator, to be honest. It just needs a little bit of a clean up, and then we'll be back in business. So the alternator's normally kind of this way round. And you can see there's a part missing, and that's where the regulator sits. So this is the regulator here, and this normally sits on the top of the alternator like that. So this has a couple of wires coming off it, and it's got a couple of brushes at the bottom which you can just see there. So I don't know how worn they are because I haven't got one to compare against, but I know that obviously this is the original alternator and the engine's done like 1,600 hours now. So I just thought, while I've got this off, I'm going to have a look at replacing the bushes in this. So I've ordered myself actually a complete regulator because they're not very much money. I'm just going to take a look at that and hopefully sort of just see if we are in a good state or not. And if we're not, I'll replace it. If we are, I might keep it as a spare. You can see the information on the top here. This is a Valio alternator, I think that's how you pronounce it. And that's the model, and you can see that it outputs 4.2 volts when it's set. So the maximum that this is ever going to output really should be about 14.2 volts. I might have said 4.2 then. 14.2 volts. So yeah, that's what it should output when it's charging the battery. Now we've seen about 13.9, 13.8, so that would account for a little bit of voltage drop between this and the charge diode, and then the rest of the boat infrastructure, really, the cabling and whatnot to get it across there. So yeah, all in all, that seems okay. Give it a bit of a clean up, sort these bushes out, away we go. So the other thing that I didn't mention was why there was a hole in the top. So you can see the little hole there. This wire, this bit of green wire, come out of that hole there, and that was soldered on the back. That was soldered on the back of that brush there. You can see here, this is where it was soldered, and that's what used to trick this alternator in thinking that it wasn't outputting enough volts. So that wire went to the Adverk battery manager. From here, this wire went onto there, through the top there, and then this was plugged into the Adverk battery manager, and that's how it used to trick this alternator into raising its voltage a little bit. And obviously when I had problems, what I did was I basically disconnected this at the main socket, and then that reverted the alternator to running back onto its standard regulator, which is this unit here, and then dropped the voltage back down to a safe level. So that was the reason why I actually took this off, because I wanted to get rid of this wire. I didn't want to just have that hanging out the back of the alternator, and that's what I was doing. I'm also going to clean in here as well. As you can see, there's a little bit of a carbon build up there from the brushes. I'm assuming the carbon, but yeah, there's a little bit of a build up there on the copper. So we'll give that a bit of a clean up. Started to clean some of the other little pieces and things, and I've got another little spade here that I've given a bit of a clean up as well. I'll just do all of that and make sure it's in really good nick before we do anything else. So when I was at the boat the other week, I measured out a couple of these little bits of cable that I need, and also what connector I needed on the end. So you can see I haven't fixed these yet. I've just taped them all, and I've got to make 2 of these. These are the little connectors, or the little terminals that go on the end, and to attach these to the cable, you basically need to crimp it on. So that's where this tool comes in. So just a standard crimp tool. This is nothing expensive. This is definitely in the DIY, you know, occasional use market of tools. It's not the best, but you can see the different size crimps at the bottom here. So we've got 6, 10, 16. That's a 4. Some really big stuff on this side. 25s, 35s, 50s and 70s. And basically you pump the handle and that then crimps your cable. So we'll just have a quick go at that now. I've used this before. It's like I say, it's not a very expensive one at all, but it did do it did a pretty good job. So we need to crimp these all up, and then when we take them back to the boat, we can just connect them all straight back up and get cracking. So on these little things, see if I can just get that to zoom in, it tells you the size. So you can see here, this one's a 16 8. So 16 is the size of wire that the terminal takes, and 8 is the size of the hole for bolting it, fixing it to whatever you're going to fix it to. So I'm just checking here to make sure that, first of all, we've got as much cable as possible in here. So, yeah, so I've measured this and made sure I've got the maximum amount of cable possible. And then secondly, that really we haven't got a lot of gaps. We don't want a lot of cable showing at this point here either. So I'm going to put some heat shrink on this in a minute once I've crimped it. But still, the best way is to get as much cable as possible in this section and no cable showing here. So I've not crimped this one just yet, but this one's a little bit easier to see. Can you see that there's wire at the top there? So I know that this one is full of wire. It's a different sized one. Slightly different design, but the wire is right to the very end. In this section here. So there we go. They're already ready to go. We'll pop this in here. We'll just tighten this up a little bit. So turn it to 1. Start pumping the handle a little bit. Bring those down. Feed my cable through. A little bit hard to kind of film at the same time, but basically now what we need to do is just pump the handle and the device will then crimp it, making sure we're pushing the cable into the connector as much as we possibly can. Now it's got really tight. Okay, so there they are with the heat shrink on now. That one's got 2 different size terminals because one goes on the engine start cable and the other one goes on the back of the alternator. These 2 are exactly the same at the moment, so they've got just the small terminal. These are 5mm, these 2. So these are going to go onto the fuse blocks, and then this end actually goes into the DC to DC charger. So there's no terminal on the end of there. I've just got to strip that wire back and basically shove it in the connector and tighten it up. So yeah, so I've just crimped them, put some heat shrink on, and that's basically it. So I've just cleaned the face of the alternator up a little bit just to get a little bit of that black off. And you can see at the back here, I've cleaned the contacts in here. They're nice and shiny now. Used Halford's electrical contact cleaner. Just a bit of tissue, just clean that all up. So pretty pleased with all of that. I'm not going to do any more. I've cleaned, obviously wiped all over the terminals on the back. So that's where that is. Now, if you have a quick look here, I've got the 2 regulators side by side, and you can instantly see that the brushes on this one are much longer. So I am going to keep this one as a spare. All being well, I'll reassemble with this new one. Hopefully, you know, no difference to the function of the alternator, but we'll reassemble with this one, and we'll put this one in the spare cabinet. So we're back at the boat today, and the job is to get this Orion XS installed on the boat. So the first task is to remove this step, then we can get access down into the engine bay to get the alternator back in, which needs to go back there, and then we can start doing the wiring and get it installed and get it commissioned. Okay, so the next course of action now that the alternator is kind of just held in place is to start putting the wiring back together. And I took some pictures of the back of the alternator before I took it apart. So I've got this connection here that goes onto this terminal here. That is a non-used wire on my wiring loom. That one goes down to the earth, along with this one here. And then we've got a wire for our rev counter which goes on there. I then got a couple of extra wires on this alternator which I'll wire on, which are to do with my engine monitoring, so we'll add those onto it after. But basically the next step is to start putting it all back together, and then we'll start tightening everything up and make sure it's, you know, it's all okay and everything's connected correctly. So recently picked up a new meter. You'll see it in up and coming videos. As you can see at the top here, it's got an oscilloscope in it. So the reason will become clear why I've got that as we move forwards. But yeah, it's got a dual channel oscilloscope in it. Standard meter. It seems relatively accurate as a meter from the reviews and things that I've seen. The oscilloscope probably not so great, but again, I'm not a sort of trained in any of that, so I couldn't really tell you what the difference was anyway. But just as a general meter, it seems really quite good. So yeah, really quite impressed with it so far. USB charging on it. It's also got a signal generator on the side, so you can generate a signal similar to the alternator for testing electronics and other devices like that. So yeah, quite impressed with it so far, and not a lot of money. So the thing I was just checking here, this yellow wire, this comes from the house bank. So that alternator knows what the house bank voltage is over there. I need to change that because that needs to be on the starter side now, so that the alternator knows, with the Victron kit all going over there and pulling a lot of power out of the starter battery, this alternator needs to know what the voltage is of the starter battery over there, not here. So we're going to change where this yellow cable's attached in a little while. But that was obviously put in as part, either as part of the original charging setup or as part of the advert battery manager. But that does need to be changed as to where that's picking up its, or sensing its power from, because it doesn't need to be on the house bank anymore. It needs to be on the starter bank. So we'll need to just change that over there in a minute. So I'm just in the process of prepping for this side of the installation now, and obviously you've seen these that I crimped the other day. So I've just cut these to length so that they will fit in the terminals correctly, and I've done the same with my negative, my ground cable. Now obviously this is quite a long cable because I've not done anything with this yet. I need to route this to the back of a switch, which I'm probably not going to show, but it's to the boat's ground. The reason I'm not going to show that is that it's kind of like a kind of a key to the boat to turn it on and off. But yeah, so this is the ground terminal. The reason I'm putting that to that switch is because I actually want this to turn itself off. So when we isolate the boat, I don't want this to be powered, and if obviously connect that to the back of the batteries, it's powered the whole time. Next bit is to prep the other side of this where the fuses go, and then I can show the installation. These terminals aren't as deep, so you can't get as much wire in there as you actually think. So if you look on the first one, the out there, I'm pretty pleased with that one. That one's really good. There's a little bit of wire showing. But I know that that is full, and that's the key thing. We want to make sure that that is as full of wire as possible, because as I say, they're not actually that deep. This one's okay. Obviously this middle one isn't good, so I need to just trim that down. I actually cut way too much off. I measured that and thought, oh, that must go right to the back, but it really doesn't. It kind of finishes just after the screw. So just a little note when you are cutting these, You know, don't cut as much insulation off as you actually think. But all of this is obviously this, as long as it sits within this bit here, just go straight down on that. That's where the relief, this little catch thing sits. Let me just grab this. So this obviously covers all of this, and this provides kind of some relief straining on the wire, and holds it in place. You also have to torque set these, so I think it's 4 or 5 Newton meters on these. I think it might be 4 Newton meters. Should also just say the reason I'm doing this out like this is because it's easier. If I had to try and jam these wires in there where it's going under the cupboard, I wouldn't be able to see that all the wire has gone in and we haven't got any sort of like loose strands sticking out. So that's why I'm doing all of this prep outside. So with my torque wrench, I've just nipped these up now, so they're tight. That's actually tighter than you think. So yeah, I was quite surprised. I thought I'd nip them up quite a lot, but yeah, just with the torque wrench here, tighten them up, and it's more than I thought. So that's that done. Come over to the batteries. So we have got our cables pulled in here. I've just stripped them back. I'm going to crimp some terminals onto the end of those so that I can then route them round here and place them in. So if you have a look at how this is set up, so obviously this is the house bank. There's two house banks on this boat. 2 house bank batteries, I should say. You can see that we've got the smart shunt, so that's the Victron smart shunt, and then above we've got this fuse here. So this is the main fuse that basically the battery house cable comes in this side, just where this red is, and then it goes through this main fuse. Now, most of things are on this side, as you would expect, so all of the switch panel and everything else, the windlass, the whole lot is all on that side. This side, you can see that there's another red cable. That is the charger cable. So I'm going to do exactly the same because my Victron is fused close to it. I'm going to connect this side, which is on the battery side of this big fuse. I'm not going to go through this fuse as well because I don't need to. I've got an independent fuse to protect it. So I'm going to connect that to there, and that'll be where we pick up the house. Sorry, that's how we put the charge into the house battery. Just back up a little bit. The starter terminal positive from the starter battery here, that's where we're going to pick up the other side to the charger. So that's how it gets its power from this battery. And the other side of that is obviously the big heavy cable that's coming over from over here where the engine is. So we just need to do that now and crimp these up, and then we can start to connect things together. So there's not a great amount of room in here, but this gives the most amount of ventilation where this one's mounted. So there should be enough ventilation around that to keep that cool. So I'm just fixing that in place. And that's the reason why I did all of these up before and did all of this, because I knew in here is going to be a pain. And I'm just using the screwdriver with a bit of tape on the end to hold the screws so I can actually fix it to this bulkhead here. And then my plan is to put my fuses here so that they're easy to get to. And then you can see these are the other red cables that are coming up from the battery. So we'll put some crimps on the end of these in a second, tidy this all up, and then we're good to test. So while I'm busy here working, this one is all snuggled in this big blanket. Are you comfy there? Are you also nice and comfy? Oh, good. Can't grumble, they did bring me back cake. So this is another bit of a situation where one job that we thought would be quite easy has turned into quite a task. So this is normally where the electrical panel is. This side of the electrical panel opens, and this side is the AC side. So obviously the boat's disconnected from the mains now, because obviously otherwise all this here would be live. So I've then taken the AC panel off. That's the aerial cable for the radio. But you can see here, this is one of the main sort of bus bars of the boat. So this is the negative bus bar. This is obviously the positive side. There's some connections that are made here, some connections that are made in plugs, and some go to this terminal here. So that is one of the main negative cables that come in. This other chunky one here goes to the windlass, so that's a main pickup, but we've got a spare, as you can see there. So rather than trying to attach it at the back of the switch, which I've spent ages trying to do and I can't do, I'm going to pick up a feed here. And that will mean that obviously when the switch is turned off, that the Victron XS goes off as well, and that's what I'm trying to achieve. I don't want it to be live when the boat's been sort of turned off and everything should be dead. So that's where I've now got to get to. Right, we are pretty much there now. So I'm not quite happy with how this is connecting. I haven't got a big enough ring terminal to put on this. So I've left a bit of cable, I'm going to correct that and obviously connect it here, but this is a 12, I've only got 10s, so a little bit of an oversight on that. This yellow cable here is the one that's attached to the alternator. So that was on this terminal, that's now been taken off and it's been moved to here. So it can pick up the voltage at the starter battery now rather than at the house bank. And then that'll just help lift or make sure that the alternator is putting out the right amount of charge to do it. So this goes to the in on the Victron. The out is up here. You can see that. There's the out on the other side. So that's all hooked up. And then in here, got a bit of finishing off to do, but almost there. These are the two fuses that protect it. So out of here into the fuse blocks and then onto the batteries. I'm not all that happy with these, if I've got to say anything about them. There's a little bit of terminal showing. The cap doesn't actually cover all of that. So yeah, I might have to put a bit of something over that just to protect that, because if it dropped on that, obviously, particularly this side, it's going to short something out. So not particularly impressed with that, but we're at the point now where we can turn things on. Right, well, I was just about to show you everything, but our starter battery's dead. Yeah, just connected everything up, and obviously instantly I thought, well, I wonder if there's a lot of current coming out of there. So I've whipped that off as fast as I could, and no, that doesn't appear to be the case. So yeah, look, nothing. So there's no high current draw. I mean, that you shouldn't do that really, but I have actually tested it with my meter and put this on amps. So if you just go through the process of doing that, let me show you. So very quickly, yep, good to go. You see that? 10.6 volts, so that's dead. So then what I did then was, this meter's got the ability to check current. So you flick across to that one, tells you to move the connectors across, plug in there, and now what I need to do is I need to jump between the terminal and the battery. Sorry, it's not the camera. And as you can see, there's no current coming out of that. There's no draw. So it's not the fact that, you know, anything that we've done really. It's just that it's dead. So yeah, it must have just collapsed. It's probably the original battery or one of the original batteries. We've not changed that, and we've had Allegra, how long now? 6 years. So yeah, we need a new one of them. Right, so as you can see, recording this on both sides, so you should be able to see this. So 14.58, so this is the voltage now going into the starter battery, so that's really good, that's nice and high. At the moment you can see that we're not charging our house bank here, it's at 12.76. I'll show you the Victron app. So at the moment the Victron controller is not enabled, it's not doing anything at all, it's disabled in the thing here. You can see here's the Orion XS, so I'm capturing this as well. So we look on the Orion XS, we've got 14.6 coming into the starter battery, that's a brand new battery. So we put that on, and then we're going to enable the charging function. So the charging function have gone on now, and in a second it should start realising, there it goes, there's the load on it, and now you can see bulk charge going into the batteries. And at the moment I've set it to charge at 30 amps, so it's held itself at 30 amps. But you can hear that drop go on, and that's now going to get rid of this. It's putting 28.2 into the batteries. The timer's gone down to 0 because there's no time left, because we're charging, so we don't have a time to run anymore, and we'll start now working away on that 10 amp hours that we've drawn out of these batteries and getting the percentage back up to 98%. As you can see, it's already bringing the house bank back up. It's pulled the starter bank down a little bit, but that's still fine as long as that stays above 14. It's charging fine, and it's working. So the next thing I'm just going to try and do is get my heat gun. I'm just going to go around a few little bits here just to check that everything's okay. We've not got any. I mean, it's already backing off already. So. I'll check down by the fuses. That is working perfectly. Check down by the batteries. It's all good. All good, that is. Really pleased with that. Obviously we're going to run it more and more just to make sure everything is working as it should. But yeah, that's working great.